So as we see, what we want to do is compare three different groups. In this case, we have shows and movies where they're rated PG or lower. And then we also have shows and movies that are rated PG-13 or TV shows that are at TV-14. Or maybe something for a more mature audience, for rated R and TV mature. And so what we're looking at is how did the Netflix users actually score these movies and shows that fall within these categories? And just by looking at the graph, there's a lot of overlap here. But it does look like it's possible that those that are intended for the more mature audience tends to have a little bit of a higher rating. We see the median is definitely much higher, as well as the quartile 1. But the entire spread is still spread out just as much in terms of the range compared to everything else. So the question is this enough evidence for us to say that users tend to rate rated R and TVM rated shows higher compared to the other groups? Well, this is what the Anova test is going to help us out with. We're going to see, is there a difference between these three groups? Another way of wording this is there an association between their Netflix user ratings and how they rated it on the content? So we're going to perform this test at a 0.01 level of significance. So as we saw, our hypotheses, what are we trying to do is when we're comparing quantitative values, the best way for us to do that is to look at their means. And as we've seen in all the other previous hypothesis tests, we're going to assume that there is no difference, that they're all the same. But what are we trying to show is that one of these, at least one of these, is going to be different from the rest. So we can usually write that in words. And the method that we call this is the One-Way Anova. So what I'm going to walk you through is how do we complete these calculations of the One-Way Anova using our ArtofStat calculator. So first, hopefully you've opened up the Google Sheets with the actual data in here. And a couple of things that you'll have to be able to do is be able to sort through these things. So on Google Sheets, you'll notice that there's a little funnel filter button here that you can click, and it'll create these filters for us to be able to look at just the ones we want. So for example, that first group of PG and lower, we can select all of the ones that are rated PG or lower. So that would be rated G, PG, TVG, TVPG, and all of the youth ones. So UR is unrated, we're going to ignore that, as well as NR, which is not rated. So when we do OK, you'll see that now we only have the PG classes or below. And in this, we have all of the user ratings. So some of these shows, though, don't have any, so we're only going to get up to the ones that we need. And we can do this for every single one of the different groups, as you'll see. So let's go into ArtofStat. So now that we have access to our data, we're going to go to the One-Way Anova. From here, you're going to see that we can select our own data. And we need to think about what is it that we're measuring. Again, these were the Netflix user ratings or user scores. And we had three groups that we're comparing. So those three groups were PG and lower. This was the PG-13 slash TV-14. And then finally we had the mature one. So that was rated R and TV mature. So these labels just help us in identifying these things later on. Now we can just paste in our data based off our table. So here I've already selected everything from the PG and lower. So I'll copy that, go into here and paste it in. We're going to do the same thing with group 2. So this time I'm going to go back and refilter these. So let's clear everything and get now PG-13 and TV-14. Those are the two in this group. And we'll copy and paste all of the ratings up to the ones that have a rating. And this will go in group 2. And lastly, we'll do this for the third group. So clear these, and now let's put in rated R and mature. And we'll copy those in. So as you can see, it creates a nice little graph here. There's different options you can do. We were looking at the box plot version of that earlier, but we can also do histograms or dot plots. But what is it that we want to copy is the Anova table, right? This is what we're looking at. So the two main things, again, that we are interpreting are the test statistic, which tells us how far our observations are from what we expected if they were all the same, and our p-value. So let's get this and put this into our work. So we're doing this at the 0.01 level of significance, and we have a p-value of 0.0953. So what does that say for our step 4 conclusion? Well, let's compare. I believe that this number is greater than 0.01. So we can say since the p-value is greater than 0.01, well, this means that our data is still likely to be seen when we're assuming the null. So if they're all equal and these are data that's still likely to be seen, then the null could still possibly be plausible. So we don't want to reject it. Do not reject the null hypothesis. And so what does this mean in terms of our conclusion? We don't have enough evidence to show a difference in Netflix user ratings between the three groups.